This is question number 3 of chapter number 5, which can be found on page number 100 of the book. The question says that a 100 kilometer 230 kilovolt 60 hertz three-phase line in problem 646. So it's talking about question number 6 of chapter number 4, the same problem. It delivers 300 megavolt ampere at 218 kilovolt to the receiving end at full load. Using the nominal pi circuit, calculate the ABCD parameters, sending voltage and percentage voltage regulation when the receiving end power factor is 0.9 lagging, unity, and 0.9 leading. So we have to calculate the sending voltage and the percentage voltage regulation in these three cases. So before we start the question, we will just take the values of inductive reactance, capacitive reactance, and resistance from problem number 6 of chapter number 4, which were already calculated. You can see them here: 0.506 ohms per kilometer for the inductive reactance, 310 kilo ohms kilometer for the capacitive reactance, and resistance was 0.067 ohms per kilometer. So because we have a 100 kilometer line, the only thing that is left for us to do is multiply 100 for the inductive reactance and resistance and divide it with 100 for the capacitive reactance, and we will find the new values to be 6.7 ohms for resistance, inductive reactance will be 50.6 ohms, capacitive reactance will be 3.1 kilo ohms. And because we know the capacitive reactance, just take the reciprocal of it or inverse of this, and you will get the shunt admittance to be J, 3.2 multiplied 10 to the power minus 4 Siemens. So the first step is to find the receiving end current by using the apparent power formula. We solve it for IR and we get it to be 795 amperes. From this information, we can first calculate the ABCD parameters by using the formula for the pi circuit. So for the pi circuit, the A parameter is 1 plus Z into Y over 2, which comes 1, magnitude is 1, the angle is 0 for this parameter. B is just simply Z. Z is actually R plus JL, which is given here. We already know these values. Just plug them in Z and then convert it into polar form or phasor form. You will get it to be 51 angle 83 degrees. In the same way, C parameter is Y times 1 plus Z into Y over 4. So again, we already have these values with us. Just plug them in here and you will get the C parameter to be 3.2 multiplied 10 to the power minus 4 with the angle of 90 degrees. And D is the same as A, so it's also 1, magnitude of 1 and angle of 0. So after finding the parameters, we will go and solve for the sending voltage. To find sending voltage, for the first part, it says 0.9 lagging. So because it is lagging with 0.9, we just get the angle of the same current, the receiving end current, 795. We just put an angle of minus 26 with it and then solve in this equation. For the pi circuit, we have Vs over square root of 3 equals to VR over square root of 3 times A parameter plus IR times the B parameter. So we have already calculated the parameters. Just plug them in with the rest of the values of the other variables and then multiply this whole thing on the right with square root of 3. We will get the value of the sending voltage to be 263 kilovolts with an angle of 14 degrees. Now the voltage regulation in percentage is actually VR but with no load, which is the same as Vs over A. So we already have the value of Vs from here. We have the value of A, which is actually 1 in this case. So it is actually Vs over 1 minus VR receiving voltage over receiving voltage, which is given in the question to be 218. So just plug in these values Vs is 263 minus 218, divide by 218, multiply by 100, you get the voltage regulation to be 20.6%. In the second part of the question, it says that calculate the sending voltage and the voltage regulation with the power factor of 1, unity power factor. So with unity power factor, the receiving current will simply get an angle of 0 degrees. Magnitude will be the same. Just plug in this new value of IR in the same formula to calculate the sending voltage, and in this case now it comes out to be 238 with an angle of 17 degrees, 238 kilovolts. Again, the voltage regulation will simply be Vs over A. Now the new Vs here with us is 238 divided by 1 minus 218 over 218 times 100. You get the voltage regulation to be 9.2%. The third part was asking us to calculate the sending voltage and the voltage regulation at 0.9 leading. So because it is 0.9 leading now, the angle will be positive 226 for the receiving current, and plug this new value of IR in this equation. You will get the new value of sending voltage to be 206 with an angle of 19 degrees in kilovolts. Now you can see, because it was leading now, the sending voltage is actually less than the receiving voltage. So just plug in this 206 in the regulation formula. 206 minus 218 divide by 218 multiply by 100, you will get a negative 5.5% voltage regulation.